Hello, math humans. We're going to do 1.5 today. We're going to be talking about statistical graphs. Our objectives are that we're going to manage graphs for qualitative and quantitative data. So as we get started, we have a couple of vocabulary words that we need to take care of. So the first one is frequency. So frequency is the number of times a data, and so data could be lots of different things, but number of times data occurs, right? We'll see some examples, so I think this will make more sense. The frequency distribution, it's a long word, long couple of words, is a listing of each data value. And data means is maybe it's a question that I ask, or it's a result from a survey. So it is the data value grouped by data set. And again, as we look at an example, some of these will be a little bit more familiar. And then the next one that we're going to talk about is relative frequency. So the relative frequency is going to be the frequency. And so remember, that's going to be how many. And then you're going to divide by n, which is the total number of responses, or however the data is organized. Okay? The relative frequency is a percent, and that would be how we report. So I've printed some of the examples out of the book so that we don't have to recopy. I don't necessarily think that you need to copy down every graph, but I would like you to copy down how we have managed the graph and the things that are said about each graph. So for example number 1, a class was asked about their favorite soda. So class was asked about their favorite soda. And this is going to be qualitative because it's not T-I-T-A-T-I-V-E, not a number that I can measure. It's just a personal preference. So notice that these would be the different students that responded, and these would be their soda choices. Okay. So the first thing that we're going to do is we're going to make a frequency distribution. Okay. And you will probably be asked to create one of these. So I'm going to write my table. So here's the soda. I'm going to draw a horizontal line. And then I'm going to have a column that says frequency. And we're going to add to this column one more item in a minute. And remember, this is how many. That's a how. Okay. Alrighty. And then I am going to add a third column in a minute. But for right now, here's what we have. So I'm going to write Coke, and then I'm going to write Pepsi, and then I'm going to write Dr. Pepper, and I'm going to write Mountain Dew, and then I'm going to have Sprite, because those were the responses from the students up above. And so then I would just go through and make tally marks. So there's a Coke, a Pepsi, a Dr. Pepper, a Pepsi, a Mountain Dew, and a Mountain Dew, a Mountain Dew, a Dr. Pepper, a Coke, and a Sprite. And then I have Coke, Coke, Pepsi, Coke. And then I have Pepsi, Sprite, Pepsi, Coke. And then I have Dr. Pepper, Mountain Dew, Dr. Pepper, Pepsi. And then I have a Sprite and a Pepsi, forgot where it was, and a Sprite. And then I have a Coke, a Dr. Pepper, a Pepsi, and then I have a Mountain Dew, a Coke, and a Coke. Okay, and hopefully my numbers came out right. So I should have 9 Cokes, 10 Pepsis, 5 DP, 5 Mountain Dew, and 4 Sprites. Yay, we did good. Alrighty, so that would be my frequency. That would be the frequency distribution. So the next thing that I would want to show would be my relative. This is going to be the third line, frequency distribution. And so what I'm going to do is I'm going to calculate the relative frequency for each of these categories. And again, they are our different types of soda. So there were a total of 33 students that responded to our little experiment. Okay, so that's the total number of students. So my relative frequency for Coke would be 9 divided by 33, because 33 is a total, 9 was the number of frequencies for Coke, and I would get 27.3%. Then Pepsi, there are 10 divided by 33, and that would give me 30.3%. And then Dr. Pepper, 5 divided by 33 is going to give me 15.2%. 5 divided by 33 is still going to be 15.2%. And then 4 divided by 33 is going to give me 12.1%. Okay, so those are the different percentages. So it's called a relative frequency distribution. Okay, so the first two columns, or the first two rows, sorry, were just our frequency distribution. It's just showing how many were in each. And tally marks are a really great way to manage that. The next row that we added was the relative frequency distribution. So the next thing that we're going to talk about in example number 2, so let me move my papers before we get there. Actually, I'll do it at the bottom of this one. So as we get ready for the next type of graph, we're going to use this information and we're going to put it in a couple of different charts. So the beginning of example 2, we're going to talk about a bar graph. The interesting thing about statistics is, depending on the way or the type of graph that I use, I can skew what it looks like the data is doing. Okay, but for right now, we're just going to talk about different ways to represent that data. So number 1, for a bar graph, the thing that's unique is that the bars do not touch. Okay, that's a U. So the bars do not touch, and they are going to represent the frequencies. Okay, each axis must be labeled. Each axis must have a title. We always, of course, want to include units if units are relevant, and then the whole graph has to have a title, and the title has to represent what you're actually looking at. Okay, so now what I want to do is I want to go to our first picture. So this is a bar graph. Notice it tells you right there the type of graph. Here is my title. Notice that each axis is labeled. So it says that this was drink. I probably would have labeled it as soda because those were the words that I used, and I would change this to soda because I think that's very relevant depending on what part of the country you live in. Frequency, remember, was the number of sodas that people chose. So if you'll remember back from our frequency distribution, we had that there were 9 Cokes, we had 10 Pepsis, we had 5 Mountain Dews, 5 Dr. Peppers, and 4 Sprites. So this is a frequency distribution, okay, and I'm going to write that right here. This is a frequency distribution. And from our example, from the first example, these were those first 2 rows. So it's just what choices did they have and how many people chose each of those 2 things. So then if you'll remember, we added a third line and we did a relative frequency. So that's going to be our next bar graph. Okay. So again, it's very similar. I would change that to soda just because I'm a little bit anal, and I would change this to soda. Okay, and again, here's our choices: Coke, Pepsi, Mountain Dew, Dr. Pepper, Sprite. Okay, and then these are the frequencies that we found, and they've written it down as a decimal. So remember, we found that for Coke it was 27.3%, which is going to be 0.273. Pepsi was 30.3%, so 0.303. Mountain Dew was 15.2%, 15.2%, and Sprite was 12.1%. So it's the same bar graph, and I'll go ahead and put these decimals in there, 0.152 and 0.121. It's the same bar graph, but notice that your two side units are a little bit different. One says frequency, one says relative frequency. And the relative frequency shows the percentage of the group that you asked questions of, okay? So you need to be very careful that you're looking at all of the information that's been presented. Sometimes people will skew data by not labeling the axes very well, and then that means that it's harder to discern what you're actually looking at. A couple of other things that we want to focus on. Notice that both graphs start at 0, which is really nice, because if there were 0 responses, we want to be able to show that. Sometimes the way that people skew data or make their graphs look better than they are is by not starting at 0. Okay, so again, we can do all kinds of tricks to change the way our data looks. All right, before I move on to the next type of graph, and I think we're going to talk about a pie chart. And everybody's seen a pie chart. The pie is the whole, and then the slices are going to represent the different categories or whatever we have studied. And it is going to be a percent of the pie. Okay, and remember, the pie is the whole thing. And so the size of each slice is going to be the relative frequency. And remember, the relative frequency is a percentage, and it's going to be a percentage of 360 degrees, which is how you would draw that. To be able to draw a pie chart effectively, you would need to have a protractor, and then you would manage these percentages as a part of the circle. So for instance, for our Coke, it is 0.273. It was 27.3%. We're going to multiply by 360 because there's 360 degrees in a circle, and I would get 98.28 degrees. So as I drew my pie chart, and I'm going to show you a nice one in a minute, then I would have a center point, and then I would use my protractor to measure out 98.28 degrees, and I would draw that on my circle. Okay, and 98 is just a wee bit past 90, so maybe if I had started here and I went to here, that would be the 98.2%. I would label this with Coke. Okay, and then I would put its percentage on there as well, which was 27.3%. Sometimes this information is included on a pie chart and sometimes it's not. So let me just do one of our other examples, and then I'll actually show you the pie chart. For Pepsi, it was 30.3%, so 0.303 multiplied by 360 would be 109.08 degrees. So then I would use my protractor, and I would put it here, and then I would measure 109, so then I would be able to draw my Pepsi map, okay? And so maybe it would be right here. And so there's Pepsi, and it would be the 30.3%. And so that would be the process of creating a pie chart. The other thing that you will notice about a pie chart is that it always has a key. And I only have a black and white printer, so my pictures are going to be in black and white. But typically, a pie chart is going to be all about color, because I want to represent my data instead of maybe including numbers, I'm going to do it with color and a key, okay? So this is the pie chart, and they chose to do it, so notice here's my percentages, and so because this isn't in color and it's in black and white, it's a little bit harder to see. It's prettier in your book, but if you'll notice, these keys respond to what the colors mean. One of the things that I dislike about a pie chart is that I have to look at both things. But oftentimes I can't fit all of this information on here, and so then I would have to have the key to make this be more self-explanatory. Okay? I also think they can be interesting because the difference between 27% and 31% is harder to see in a pie chart than it is in a bar chart. So if you'll remember, here was our bar chart. Here was the 27%, here's the 30. So sometimes a linear relationship is easier to see the difference between than it is if we use a pie chart. So pie charts are often used for qualitative data, okay? Notice that it has a title. I'm going to change that because I think it's more polite. And then we would have our data. So there's actually less units on a pie chart. The next type of picture that we're going to have is called a pictograph. And a pictograph isn't used very often, so not used often, but it is entertaining. And so it uses pictures to represent the data. S-E-N-T, spelling is optional, uses pictures to represent the data. Okay? The thing that has to happen with a pictograph is that you have to have a key, and it has to tell you what each picture represents. So in the example I'm about to show you, they decided to measure or use pictures of a cup, and it's a pretty ugly cup, but they decided to use the picture of a cup to represent how many people chose which type of soda. And then they have to tell you that each cup represents a frequency of 2. Notice that it's not 1. And so if I look at the pictograph, here would be the pictograph from your book. Notice that for Coke, it's 2, 4, 6, 8. We would assume this is about a half, but this is one of the reasons a pictograph can be annoying. Is that a half a cup? Is it 2/3 of a cup? Is it a third of a cup? So it's not as precise as some of the other types of methods. Okay? So that's kind of an interesting type of graph. All right. So now what we're going to do, all of these have been using qualitative data. So remember that that means maybe what is a characteristic, it's a like, right? So what type of soda? It's not quantitative data. So now we're going to go to means of graphing quantitative data. And remember, quantitative data is data that's all about numbers. Yeah, math. So for the frequency distribution, we're going to take our data and we're going to subdivide it. So we're going to data is subdivided into intervals. Okay? And so in those intervals, we're going to have a low limit, we're going to have a midpoint, and then we're going to have an upper limit. Okay? So the difference is going to be what's called a histogram. So a histogram is a bar graph, and it touches. The other thing that's relevant about a histogram is that we are actually, the height of each bar is the midpoint of the interval. We'll get to some examples about that in just a second as I wake my computer back up. And it means that I have to type well. Okay, so now let's move on to some of our examples, okay? All right, so I want to do a little bit. So this is a frequency distribution for the energy that's used by different countries, okay? So the lower limit is going to be 142, the upper limit is 1537, and then this is the midpoint. Remember that midpoint is going to be upper minus the lower, and we divide by 2 because it's the middle of the bar. So the midpoint is actually going to be the value that we show, or the height of the graph. And I'm going to write that it is the height of the bars. Okay? And then notice that I have a frequency for all of these different countries. But notice that each of these have a lower and an upper, lower and an upper, lower and an upper. And then in this column, they've given you all of the midpoints. Okay? So now let's look at, so this was our distribution. This was how we collected our data. Now let's look at the graph that corresponds with that. So let's talk about energy use per country in worldwide in 2010. So really old data, my bad. So notice that we have a lovely title, okay? Notice I have energy use, and it tells me what the units are. So we always want to make sure that we include the units when we're talking about quantitative data, right? Again, this is a quantitative, meaning it's all about numbers, okay? This is my frequency, so it's very similar to the graph we just did, but notice that all of these bars are going to be the same width. So if I write back up here, bars are the same width. One of the ways that people change the appearance of the graph is by changing the width of the bars, and so that is bad math, and so it changes the appearance, and so that's one of the things that we look for when we're looking to critique a particular graph. Notice that they've told you that the heights are down here. They're on a diagonal because they won't fit because the numbers are big, okay? And so these would be all of how much energy was used, and then this is the frequency. Notice that the majority of the countries are using about 839.5 kilograms of energy, of oil in their energy. Okay, and this would be the countries that responded to the survey. All right, so the differences between a bar graph, let me write differences. Differences between a bar graph and a histogram. Okay, a bar graph, let me scoot this down. A bar graph, the bars don't touch, and it often represents qualitative data. Okay. On the other hand, for our histogram, the bars do touch. The height of the bar is the midpoint. Okay. And I think those are the two primary differences. And again, notice that we're talking about frequency, and then these are the numbers of frequency down here on, or sorry, this is the amount of energy, and these are the frequencies that it represents. So when we look at our different types of histograms, we can talk about the shape of the graph, and that becomes very important as we look in data, and as we move on further into Chapter 2, we'll start talking about data. Notice that this data is a nice symmetric curve, and then this is going to be an important point to talk about later. Okay, this data has a nice little curve to it going this way, and notice that we call that data skewed right, which I think is a little bit weird because I would have said it's skewed left, but this is the way our book is calling it, skewed right. Notice that the least amount of frequencies are over here, okay? And then on this one, here is our lovely curve going up, and notice this one is skewed left. Again, they are histograms, so the bars touch, and I am graphing the midpoint of each interval, okay? Alrighty, so we want to be able to draw conclusions from our graphs. As we move along in our study of statistics, we'll talk about the shape and how those are relevant. But for right now, there's a couple of things that we want to make sure that we talk about when we're looking at graphs. We want to look at the labeling. Okay. Is it complete? Is it thorough? We want to look at the title. Does the title describe what's happening? We want to look at the units, and each axis must be labeled. If we're looking at a histogram, which these are, and remember that's where the bars touch, are the bars the same width? And that's really, really important for the overall shape of the graph. All right, my dears, that is it for today.